Hello, just making a short video regarding balancing a chemical equation by heat and trial method. Now we know that suppose AA reacting with BB, this gives you CC plus DD. This is what? Chemical equation. What is it? It is simply a way out to represent a chemical reaction in its own way and process. Now here the small a, small b, small c, small d are stoichiometric coefficients of the reactants and the products. So A and B are reactants and C and D are products. Now A, B are stoichiometric coefficients of reactants. C and D are stoichiometric coefficients of products. That means A amount of A reacts with B amount of B, giving you C amount of C and D amount of D, or A moles of A reacting with B moles of B gives you C mole of C and D mole of D. So again we can directly say that AA plus BB, this gives you CC plus DD. These are the reactants and these are the resultants or simply products. Okay, fine. Now coming to the next part of the story. I'm just moving the phone like this to make you understand. Cannot access the board at present, so using my phone only to get the thing done. So we need to balance a chemical reaction. So balancing a chemical reaction by heat and trial method. This is the best methodology to balance. You can also balance by algebraic method. That's a different realm. I'll come to that. It's a different realm. So here I'm just balancing by using the heat and trial method. Suppose you are given a chemical equation like this: CaCO3. It gives you CaO plus CO2. This reaction is the unbalanced reaction or the skeletal reaction. It is the unbalanced reaction or the skeletal reaction. This needs to be balanced. So here, according to heat and trial, we need to count the number of atoms of an element in both the sides, whether or if they are same in number. If the number of elements are not same, then we need to balance them by using some numbers. So count here: one calcium atom, one calcium atom, one carbon atom, one carbon atom, oxygen is 3, 1 plus 2, 3, one calcium, one carbon, 3 oxygen atoms, one oxygen plus 2 oxygen atoms. So 1 plus 2 equal to 3. So all the number of atoms are same, hence equation is balanced. So we don't need to put any stoichiometric coefficients. What are stoichiometric coefficients? These are the number of moles or amounts that are required for a certain substance to react accordingly with others to form corresponding products. Coming to it, now you suppose you get this equation: Na2O, very common reaction I'm writing, plus HCl. You get NaCl plus H2O. Now count. There are 2 atoms of sodium. 1 atom of sodium. Sodium is unbalanced. 2 atoms of sodium. 1 atom of sodium. Sodium is unbalanced. 1 atom of oxygen. 1 atom of oxygen. Oxygen is balanced. 1 atom of chlorine. 1 atom of chlorine. Chlorine seems to be balanced. 1 atom of hydrogen. 2 atoms of hydrogen. Hydrogen seems to be unbalanced. So sodium and hydrogen need to be balanced, while on the other side, as furnished, oxygen and chlorine are already balanced. Our first job is to balance the elements which are unbalanced. Here sodium is unbalanced. It is the metal, so starting with it, not a rule but simply a convention that's just going on. So number of sodium is 2. You put a 2 here. Now you count 2 atoms of sodium, 2 atoms of sodium, or maybe 2 more, whatever you say. So number of sodium is same. Now number of chlorine, 2 into Cl, so 2 chlorine. Here is only 1 chlorine atom. Now chlorine got unbalanced, needs to be balanced. You put a 2 here. Now count 2 atoms of sodium, 2 atoms of sodium, 2 atoms of chlorine, 2 atoms of chlorine, 1 atom of oxygen, 1 atom of oxygen, 2 atoms of hydrogen, 2 atoms of hydrogen. The equation is now totally balanced. It is a balanced equation, right? It's a balanced equation. So by this we can balance. You can take another example. A good example is here. You consider this example. Zn plus HCl, ZnCl2 plus H2. Zinc is balanced. Chlorine is unbalanced. 1 chlorine atom, 2 chlorine atoms. Hydrogen is unbalanced because 1 hydrogen atom, 2 hydrogen atoms. In a balanced chemical equation, the reactant side and the product side must contain same number of atoms or same number of atoms of that element. Clear? So this we should keep in mind. Now we are just balancing it. So zinc, it is balanced. Chlorine is unbalanced. Put a 2 here. 2 into Cl means 2 chlorine atoms, 2 chlorine atoms, 2 hydrogen atoms, 2 hydrogen atoms. So this is the way by which we can balance. It is called the heat and trial method. I hope it is clear. Now another thing, let me mention. Generally, suppose I'm writing like this: Na2O plus HCl. This gives you NaCl plus H2O. This is unbalanced or skeletal equation. When you balance it, you get Na2O plus HCl, NaCl plus H2O, Na2O plus 2HCl, 2NaCl plus H2O. This is an example of balanced equation. But when you mention the corresponding state of the substances that are involved, for example, Na2O solid plus 2HCl aqueous, you get 2NaCl aqueous plus H2O liquid. This we call complete, this is called complete or completely balanced chemical equation. Completely balanced so all complete equations are balanced chemical equations, but the reverse is not true. So I'm just putting my phone like this so that you can see the things very clearly. Just turning the copy around, putting it like this, so you can see the unbalanced equation, the balanced equation, and the completely balanced equation. I think it is clear. It's just a video because I'm not with the board at present. I'm just at some other place, and I just got this rough copy to deal with, and suddenly I was requested to make a video, so I just made the video. So one thing I can do later on, I can make a video of balancing equations and put it as I do in the board. So till now, just it's a just video. So I hope it is clear till now. So I'm ending up my video. Good night.